Hello, Pythonistas. This is the welcome to the last session of the day. Here is Kushal Das. He's going to talk today about building reproducible Python application for secure dev environments. So the stage is yours, Kushal.
Thank you. Hello, can you hear me well? Okay, before I start talking, I want to give a shout out to my friends at Chicago Python user group. Hi, all my friends there, and let's start. Before anything else, a little bit about myself. I'm a public interest technologist with a small nonprofit called Freedom of the Press Foundation, where we try to protect, defend, and empower public interest journalism. So we mostly work with different kind of media orgs. We do digital security training. We write software. We help them to make their security better. I'm also heavily involved with various other nonprofits and open/free software projects. One of them is something we all know here, Python Software Foundation. I'm a director at Python Software Foundation, also a code developer of the CPython, the programming language itself. And I'm also a core member of another nonprofit/project known as Tor, where we try to make sure that our human rights can get defended and we can maintain our privacy. So I'm going to start the actual materials of the talk now. So I'm going to guess that many of us are here Python developers, but you're going to learn about one thing, that this whole talk, we're not going to talk about anything new tools or new systems. We're going to make sure that we're going to reuse whatever is already available to us from the community. So a very simple Python application, I'm going to just use it as an example. And as developers, we always think it works on my laptop and job done. But as we know that organizations and companies do not work in the same way. So for the same Python application, we may run it on one server. We may execute/run it on different servers, or this magical thing also known as cloud. There are different ways these applications get into these servers/computers/cloud. One of the easiest steps is to use the source code management system itself. I'm going to mention Git because that's one of the most highest used these days commonly. Then if you are on a Debian/Ubuntu world, you may want to use .deb Debian packages. If you are coming from a Fedora/CentOS/Red Hat world, you may want to use RPM to deploy your final application. At this moment, many of you must be thinking that there is another way of deploying in the modern world. Sadly, this is not the right talk for that. I'm going to talk mostly related to things on the Python world. A little bit about the actual project. So I'm a maintainer for a project known as Secure Drop, which is an open source whistleblower platform. It means anyone can securely and privately leak information to different media orgs so that they don't get caught by, let's say, their respective governments or any 3 or 4 letter government agencies. Secure Drop is deployed over 75 media orgs, including New York Times, Washington Post, Guardian, Intercept, and various other orgs. So this is what the sources see when they go and try to leak any information over Tor browser. The journalists in those organizations, they have to get into a locked room inside their org and boot a Tails operating system-based laptop where they will see something like this. You can think like this as an inbox, correct? Where you can see different random names, where you can click and download any of the material or messages. But the part of the story is these all documents are encrypted with a key which is not available on the same laptop, which is there in a second computer which is air-gapped. Means now the journalist has to somehow take those documents using either a USB key or write one's CD-ROM/DVD drive, and then bring it to the next computer, and decrypt those files, and then view the documents. And this whole process is kind of taking time. It takes almost like 40 to 45 minutes for every journalist to go through the documents they want to view. So it brings up a question between security and usability. Because in our case, the nature of the kind of post or project secure drop works, nation state actors are always a pretty good advisories for this project. So we have to choose between two. And in this particular case, we should always try to get some help from professionals. Luckily for Secure Drop project, we got someone named Nina who really helped us to build the next steps. And we have something like this, which is in the alpha level, which is a desktop application for the journalist. And from the look and view, you can understand it's just another normal application. But that's get deployed on a special operating system known as Cubes. Cubes-os.org is the website. Cubes is a reasonably secure operating system which uses Fedora/Zen to build up such a system where each and every application may run in different VMs, and within the same laptop or desktop, you can actually have air-gapped VMs where you can store your private keys and details. So this really brings in the both worlds a little bit nearby, the security and usability. And that's the future we're looking at. And we particularly deploy this application in using Debian packages. So for the rest of the talk, when I will say Debian packages or Debian, that means a Debian VM inside of Cubes OS in a computer. Now the question is, what all things can go wrong security-wise? I'm sure all of you have different ideas and different stories. I'm going to take a few of those which recently came in my mind to share with all of you. A few months ago, ASUS figured out that their signing keys were taken over by some attackers, and they managed to sign some malware and post across to multiple millions of people's computer, I guess. There is another example in another programming language world where is a really important used library got malware. And in our Python world, if we see, in last year in 2018, there were some tries to put in malwares using some typo squatting, where people wrote a project which is almost similar name of a known project, and they tried to put in some malware which in turn tried to steal Bitcoin wallet addresses and details. Those are the few, three examples I put in here. But this is not the end of our attack sites. Few years ago, this particular gentleman, Mr. Edward Snowden, also talked about a document, I Hunt Sysadmins. That particular document is about few, let's say, 3-letter government agency folks who loves to visit different conferences and at the same time try to find sysadmins to various infrastructure and get their credentials so that in turn they can own those infrastructure and figure out and decide whom to kill next. Part of the mission. I don't want to make you paranoid, but it might so happen that such people may be sitting just beside you or behind you. The threats. So all the points I mentioned one after, we can summarize them into 4 simple points. The source can contain malware. Let's say that someone got access to the developer's laptop and changed some code which developer never noticed of our dependencies, or the source is totally changed. Binaries can be replaced with malware. If the advisory is powerful, they can do man-in-the-middle attacks while you are downloading the source or binary. The storage of the web server, or in case, let's say, the whole infrastructure can be compromised, correct? And we all know some stories about these things. So we're going to see how we can mitigate these issues. The simplest solution to that starts with one point: review your dependencies. It's important, and I'm going to get into that more. So as I said, we are a Python project. We use ppnv a lot. So ppnv can help us, or ppenv, whichever way you want to pronounce. Ppenv helps us to create a requirements.txt, which will look something like this, where we mention the project or slash dependency name and the version. But we do not want to use this. Instead, we want to use something like this. Sorry for the size thing, because not fit in one line. So it's basically the project name, the version number, and a SAR256 sum of a binary wheel. Wheels are the binary package built from the source tarballs. In our case, we want to make sure that we can use only the wheels which are built by us. So that's the end goal part of it. Now to do so, as I mentioned in the beginning, we never created a new tool. Instead, we have a makefile. You can understand long-time Linux users, and also a few bash/python scripts which help us to create all of this. One of the steps there is called build-wheels. This is the step. You can see that it has 4 different commands, different scripts it's actually running. The last script just creates a URL of all the tarballs and the source, binary wheels we created. The first script, verify-SAR256 sum-signature, that verifies that it exactly matches with our signatures or not. And the build and sync wheels, now we're going to go in depth to see what we do there. So we also have a separate file known as piffile.lock. It has the source hashes and all recursive dependencies. So what we do is that we create a temporary requirements.txt with only source tarball hashes. And then in our script, we execute this pip3 command, which only downloads the source tarballs. You can see that we are telling it, do not download any binary wheels, get me all the source tarballs. And then we re-verify that, because we are passing --require-hashes, it re-verifies that all the hashes match. Then another pip3 command helps us to build this into wheels. These are standard commands from pip. And we rebuild all of those tarballs into wheels now. At this moment, because we have freshly built wheels on the system, we can now create this requirements.txt file, which has the SAR256 sums of the wheels which we built. And the maintainer of the Python project, that is us, we can create a source tarball of our own, setup.py sdist. This will have a requirements.txt with our own wheel signature. At this moment, many of you may have the question, we never checked the dependency source code, correct? We just happily assumed whatever came from pip is valid. So to actually rectify this step, we have a rule. And to follow on the rule, we use a tool called diffoscope, which helps us to create a diff between 2 different tarballs. And then at least 2 human beings, 2 developers, manually go through the diff of the whole change to verify that this particular source code tarball doesn't have any malware or any code which is connecting to random sockets on internet or tries to download code, or let's say doesn't have base64 encoded lot of data, which is not supposed to have. So we verify all these steps and then only allow any changes in the updates or the dependencies for each and every dependency. And we actually stored those dependencies in a file called SAR256 sums.txt. You can imagine from the name that it's just names of all tarballs and wheels. At the same time, the SAR256 sums. And then we sign it with our keys, which are not on the system. All are always either on air-gapped computers or on hardware tokens. And we keep the same file, signed file, there so that anyone can verify. And our tools verify the same couple of times. At this moment, we have our source tarballs, we have the wheels. Now we have to make sure that we can consume those wheels. There are different amazing technologies, but luckily for us, in Python world, we can just use a simple old technology also known as HTML files. We can create some index.html files which can enable us to create a private repository, or says our own repository, which will provide pip files, the source tarballs and binary wheels, and pip will work. If you want to know more later at home, you can search about this pip, pip 503. This has all things in details. Here are two examples. This is the top index page. You can see it has just links to different projects. And if you go into any of the projects, it will have URLs to each tarball and the wheel file. Static files which we can verify, commit to GitHub, and deploy anywhere we want. Static files, correct? Up to this, we managed to get source code. We managed to build them into wheels. Now let's talk about deploying the actual application. How do you want to do this? You can raise your hand about, how many of us already saw this before in life or did this. And we can always say that this is dangerous because a Python dependency will change things into your system Python libraries, and this may go very bad or sad at the same time. So for a remedy, we know about virtual environment, correct? We use it to develop our applications. What about just packaging the whole virtual environment instead? And then we figured out in the last PyCon that we are not the only people who are thinking about this, and Donald Stapp actually pointed us to a project named dh-virtualenv, which is coming from Spotify, an open source project which modifies and adds some extra layers on top of Debian packaging so that you can install, build, and package a whole virtualenv for your Python application. In that way, you can actually now control all the Python dependencies of your application, and you can install it easily in a virtualenv, and you can still package it automagically. Here is an example of the rules files. There's too much of text, but if I just try to click this line, you can see that we are saying we are using Python 3.5, setup.tools, and the index. This is the index we use at Secure Drop, so you can actually open it up in your computer later on and find it out. And you will also find that this particular makefile has 4 separate commands at the end, a couple of find lines. So using those things, we try to achieve the next level, that is reproducible builds. This is actually enabled from Debian Stretch onwards, all Debian versions, where it will help us or anyone else to be able to produce the exact same artifact from the exact same source code. So it doesn't matter if I'm building the Debian package today in my laptop or in our production system, or if tomorrow you want to try to build the same package again, we will get the exact same final output. All of these things together help us to create a secure, usable, reproducible builds. The things it has are authenticity. You can actually check who made those builds. Those are signed with our keys. You can have auditability, correct? You can have reproducibility to have exact same build and outcome, that whatever software you are installing for your secured environment are exactly what it's supposed to be, not anything fancy. Now, these steps together can help us to mitigate those threats we started from. The first threat, source contains malware. So this is the step where we do the human review to make sure that the source tarball is what it should be. And then we store and sign the SAR256 sums with GPG keys. Now that also helps us because we also store the SAR256 sums of the binary wheels. That means binary cannot be replaced, and throughout our build process, there are many places where we double check or triple check or the same keys and the values of the SHA-256 sums. Man-in-the-middle attack, it's taken care by two different things. Again, HTTPS, which is the standard thing everyone should now use, plus the SHA-256 sums, so that the final thing which comes down to the computer, and Debian packages also, they make sure that it's the exact same thing. Because none of those signing keys are there on a network connected box anywhere, so we also make sure that just in case our infrastructure / web application / web server gets compromised, that no one will get access to those keys, that they can replace the actual any of those signed files. Like, this is a way, correct? One can try to push a new malware or new source into our system. And on top of it, using the reproducible builds guidelines, we managed to create the reproducible builds, which at the end give us certain amount of secured idea, where we can really say that these reproducible builds helps us to verify what we are finally running. And I can tell you one thing honestly, that it sounds a lot of steps, but even before this talk today at PyCon, for the last few days, I was showing the slides and the ideas to various other people in this conference who actually are much more better experts than me on this, and all of us actually agreed that this step looks much more saner to make sure that we can reduce those threats. Here are a few links. Freedom.press is the website of our organization. securedrop.org is the primary website for Secure Drop project. Those URLs where you can find those scripts and all the other scripts / makefile. And it also contains the update policy on us. And because this is available only for Debian, I wrote a similar thing for RPM packages, just in case any one of you want to deploy the similar thing for RPM-based operating systems, say Fedora, CentOS, RHEL, you can use the same thing. Thank you. I'll be open up for questions now. Any questions, anyone? Yep, here. I'll repeat. I can repeat, you tell me.
Okay, so have you ever heard about the Nix package manager? Because it incorporates some of this verification process, and it's kind of part of built-in.
Yes, we know about Nix, but the idea is that because we are so much already into the whole idea of using Debian / Ubuntu-based systems, and the kind of small team we have, we cannot make a lot of changes at the same time. So the idea was like, let's try to do what we can do or achieve within staying the same like operating system level where we are, and something which just works out of the box. That's why we chose to add all of this inside the Debian package we install. Any other questions, anything? Yes.
Hi. So for Secure Drop, I'm curious as to what went into the decision to set it up the way that you did, as opposed to considering things like blockchain or trusted execution environments?
Okay, number one point, I'm not a blockchain expert at all, number one. Number two, our idea was like, again, as I said, like we want to use the tools and technologies already available to us, which is being consumed all across the Python environments. And we, as I said, like we found this is the most common thing which we can use. And there are a few times where people came and told, like I know me personally that, oh, you can use blockchain to solve all your security problems. And my general answer to them is, why don't you come back with a PR? So I don't know anything about blockchain other than it's a database, some sort of, like, yeah. Sorry, that's my answer. Yep, next question, please.
You have, you're hosting your own PyPI server. For that, so you're building a virtual environment and you're packaging that up. So the end user is receiving a Debian package, but they're not actually, from installing that, interacting direct with that PyPI server. Is that correct?
Correct. So the virtualenv already has all things installed.
Your PyPI server is just internal at this point, right? are you exposing that as well, such that people can, for transparency purposes?
Yes, so this is the URL of the server which we are using now, dev-bin.ops.securedrop.org, and any one of you can actually open that URL /simple, that URL. So it's public, but it's only used while building the Debian package instead of end users. So end users just use the Debian package, which is already ready for consumption. But everything is public because the idea is you should not have to trust us or what you get from internet. You are supposed to be able to verify and audit what you are using.
Yeah.
Yep.
And then just one more quick question. It was, you're doing PGP encryption on the text file containing all of your checksums. Was there kind of a process where you experimented with like signing the tarballs or signing different portions of it such that putting all the checksums into a text file and signing that was the most efficient or simple?
Yes, because it stores. We stored that file inside our Git repository, and we trust the standard HTTPS thing we are doing, and instead of trying to reintroduce or redevelop anything new, and because we trust also our GPG as a tool for the whole project, we just go with GPG.
Awesome.
Thank you.
Hey.
Next.
Hey, so great talk, thank you. So I just wanted to give a suggestion that there's a tool called FPM that you can use to specify the type of package that you want, and when you run it in any folder, it packages up the whole thing into an RPM or a deb or whatever you want. So we at work, we basically do the same thing that you do, but instead of using different tools for different types, we just use FPM that gives you a lot
Thanks for the suggestion.
of flexibility. That's open source too, so you can check it out. So,
Yeah, I am coming from a Fedora packaging background. I spend my life with the Fedora project, and I also package things for Debian and Ubuntu in a different capacity. My personal finding as a packager, I found having separate package builds for every system works pretty well. Next question, this side.
When you're making your builds for Debian, do you have a separate process to make the builds for Ubuntu? Because I use virtualenv to create builds for Ubuntu, and they never work on Debian. Or I can create them on Debian, and then they don't work on Ubuntu. Have you run into that, or is that, are you trying to support both?
So the idea is that you make sure that your build environment matches with what you are running end. So if you are running, say, building for Debian 9 stretch, and latest Ubuntu, whatever version number, you have to build two separate packages because they will not be compatible with each other. And if they contain ASO files, that is binaries, it will not work, basically. So that's the way to work.
Thank you.
Thanks.
Hi, thank you for the talk. I've noticed that you consume from PyPI on the source packages intentionally, which means that in your Debian build depends, you will be required to provide all of the build dependencies of all the pip packages that you have, all of the C extension packages that you have. Has it been a problem in any way? Was it a concern? Did you have to have a build depends of the C extension packages that you consume from PyPI to be in your build depends list?
So the question is, did you get into any kind of trouble while building any kind of C extensions? Till now, no, because the biggest C-based thing, we have two. One is cryptography, and I think PyYAML also has now C extension, and no. So I think we required only one of the dependencies, which we added as a build requires for the package, and make sure that it exists. Thank you.
For Diffoscope, have you found anything interesting while reviewing all those changes? And a second question, in reviewing all of those changes in your dependencies, do you run into review fatigue, and how do you deal with that?
Correct. So the question is about Diffoscope. Have we noticed anything special? No, it's just that a long set of text one has to go through, which creates the problem. And we're talking to more and more projects / people. We found that many other companies also do the same internally. So one of the things I'm planning to work on, maybe just after sprints or during sprint, is we'll try to create a way where different projects / people whom we can trust can publish this information. Right now at SecureDrop, we are publishing it in our GitHub. So github.com/freedom of the press. In the Debian packaging, the actual repo. I am signing the whole change with my GPG keys and putting it up in the wiki, which is not working right now here, network. But yeah, it's going to create a lot of pressure. But the more people I talk to, everyone says manually reviewing the source code is the only way to make sure that the source is clean. So we have to find out a way as a community so that we can actually start trusting it more. Thank you.
Thank you.
Okay, I guess no more questions. Thank you.